My name is Sean Leach. I'm the Vice President of Product and Chief Security Officer at Fastly. The length of my title is 50 characters, if you recognize the Python. Previously, I was at VeriSign, Name.com, UltraDNS, Newstar. So I've been in kind of this DNS infrastructure-y world for quite a while. How many here know who Fastly is? That's cool, thank you, that's good. I was at a talk a few months ago, and there weren't as many people who've heard of Fastly, but I definitely have noticed that the levels are increasing. So who is Fastly? These are some of our customers. We love our customers. We're very passionate about our customers, but and it's funny too, wherever you present this logo thing, like Imager is obviously huge in the US, and not many people know about it as much in, say, the UK. And then obviously Twitter, and we got a lot of Gov.uk, the GDS folks. They had some cool talks today. One I'm actually competing with right now for a time slot. So thank you for coming to mine as opposed to his, even though we're huge fans of the Gov.uk/GDS folks. So that's who Fastly, those are some of our customers. I like to show that to people because I love this wall, it's really cool. We're also huge open source fans. We give free CDN to any open source project. So if you have an open source project and you need CDN, please come talk to us. So Fastly is a CDN. For those of you who did not raise your hands, we are a CDN. I have another slide that says what we do, just because I kind of have to show you or tell you what we do. I don't mean to sound like a salesperson. I definitely do not want to sound like that. But we provide free CDN for Ruby, Python, Debian, Varnish, anybody here who's open source and wants free CDN for your open source because you don't want to have to pay for the delivery bills, or you just want your site to be a lot faster, come talk to us. We give it to you for free. Who is Fastly? Marketing-y stuff right here. Basically, we do a lot of really big servers with a whole lot of RAM, 768 gigs. I know a lot of you have that in your desktop. I aren't as impressed, but if you don't, we have 768 gigs of RAM, like 8 to 12 terabytes of SSD only hard drives in our machines. We have our own custom kernel. We wrote our own network routing software that runs on top of Arista switches. We do a lot of software development, so we're very much a software-defined. I'm not going to say software-defined networking, because that's a buzzword, but we're a software-defined CDN where we've written most of our own code. So it's pretty cool. So I'm going to be talking about security. Like I said, of my 50-character title, one of them, some of those characters means Chief Security Officer, so I have to deal a lot with security. And with the customers that we have, as you saw on that board, and others, we have a lot of security thingies that we have to deal with, right? So I love this picture, security fail. They got a little gate there, and you can just walk around it. There's whatever, sorry. It was funnier when I put it on there. I thought you guys would laugh more, but that's all right. Thank you for the courtesy laughs. Courtesy laughs are all around. So there we go, web app security. So web apps, the reason I thought this talk would be useful here is I know developers a lot of time, they spend a lot of their time deciding what framework I'm going to use, what the latest kind of like buzzword technology that I want, or the way I structure my apps, the development methodology I use. But a lot of times they overlook and they just kind of expect everything to be secure, right? I just write this stuff and it's magically secure and it's amazing and it's awesome, right? But in reality, security, there's many aspects of security that go into building an application. Oops, I bumped this thing. There we go. I'm also really, I wave my hands around a lot, so if you get dizzy, just raise your hand. How's that? So, sorry, ignore me for a second while I put this back on. See, as you can tell, I move around my whole body around a lot, so I knock the mic off me quite often, even though it is the first time I've ever done that. So you witnessed history. All right, so security, it's really important. It's often overlooked, et cetera, et cetera. So this talk, I'm going to apologize. Oh, there's already a question. I'm going to apologize in advance if some of this is like, oh, God, I don't want to learn about crypto today. But I'm going to try and go over a full gamut of things that are interesting in the security. And I hope that at least like one of my slides is interesting to you and you learn a few things about this. And feel free to ask questions at any time, throw things at me. I'll admit I'm not the smartest person in the world. I'm a mile wide and a couple inches deep, but I'll try and answer your questions as best that I can. And if I can't, I'll just refer you to somebody who's smarter. I'll say, just Google it. All right. So first order of business, cross-site scripting. So this is an interesting one that goes back a long time where basically the goal of cross-site scripting is there's a lot of user-generated content out there, right? You're commenting on a site, you're uploading, a document to be parsed, you're posting photos, etc. Cross-site scripting is an attempt to get an attacker's content on the website and ran within the context of that website, right? So here's a classic example of that. This person, Pierce H. Delphin, ZZap, great Twitter username. He was able to get a Twitter cross-site scripting such that there was an JavaScript alert box, right? Seems innocuous enough. Oh, wow, an attacker got me to have a JavaScript alert box in my browser. But where this is interesting is actually if that JavaScript code that the attacker is able to get you to run has access to your session cookies or your session ID, for example, right? When you log into a site, how many here are developers? System admins? That's cool. DevOps? Network engineers? Are in the wrong room. They were at some other seminar and they went in the wrong room. They didn't want to leave yet. No. Okay. So as a developer, right? You've written the code. You've logged in. You've returned back the session ID, either embedded in the URL or maybe it stores the cookie. An XSS attack now has access to that value potentially, and there's all sorts of services where that'll automatically post that back out to attacker's website, where they instantly have your session ID, where they can pop on and assume you as if you had logged into the website, right? Anybody here do IP verification of a session ID such that if a session changes from one IP to another, you flag it or invalidate it? Nice, 2, 3. So 3 out of, how many are here, 200? 150? So not saying you should do that or you shouldn't do that because there's problems with that too with things like NATs, et cetera. But as you can see, this is a very simple attack that can happen if a cross-site scripting attack is enabled or is able to be exploited on your site. And there's a whole bunch of other words on here that I'm not going to go through. See, I'm having a hard time too because this is an hour and a half long, and I've always talked for 50, 55 minutes. So I might talk slow to get to an hour and a half. But no, I'm just kidding. I'll let you guys can go early if we get done early. So how do you fix a cross-site scripting? So there's a few ways. Some templating languages are safe by default, like Jinja 2, which is a Python-based templating language. It will auto-escape template content on the way back out. Like it'll strip out things like script tags and others. Angular has a function that you can call. PHP has a function you can call. We've actually seen a lot of people try and do what's called blacklisting, where they'll write this function that tries to find and block known tags that are dangerous on output, like, oh, use this regular expression to filter out all script tags. The problem with that is the HTML spec is changing all the time, so you maybe are missing some new scripty tag that allows you to run script on it. Not to mention that there's ways to get around that with different character sets and escaping of content, et cetera. So what we usually recommend, and the OWASP. So OWASP is the OWASP. Everybody familiar with OWASP? That's pretty good. So open something security something. It's a cool site you go to that gives you examples of how you should make your code secure, right? So that's one of they have a whole page, I wish you could just click on that right there and it would take all your browsers to it. But what that does is it gives you some rules to help with prevention. We actually recommend whitelisting is a better way of doing it, meaning I'm only going to allow these tags on my content. Because let's be honest, you don't need the blink tag in your content that gets generated, right? There's only certain tags that you care if somebody's typing on Reddit and they hit submit and there's a comment that shows up. How many tags do you really want in that comment? Let's just be honest, right? You don't want them sourcing, anyways. And then there's a lot of best practices as well, like the cores, JSONP, and then there's some the Jinja 2 security test suite does some cool stuff where they test to see if they're properly doing XSS protection for you. That's one of the tests that the developers have created. WAF, this is another one. How many here, I love to ask this question. You're gonna be like, why? That's a stupid question, but WAF, how many here have a WAF in front of their website? Or no, how many here know that they have a WAF, or don't know if they have a WAF in front of their website? How many don't know what WAF stands for? That's all right. Web Application Firewall. You learned something today. Write that down. You tell all your friends and family. So a WAF is basically something that sits in front of your website, looks at all the stuff coming in, and then tries to filter out known bad stuff, right? Pretty simple. So as a firewall used to do for your home computer, where you'd say, I'd only allow these ports in, or if you were using like BitTorrent, you had to open up like 4,000 ports into your house to be able to get access to the BitTorrent network. A web application firewall looks for folks, and for some of these things I'm going to be talking about today, looks for these attacks and tries to filter them for you. So one way of blocking an XSS attack is to use something like a web application firewall. It's like a stopgap really, where if you put it in front of your app and then say, oh, I don't need to write any secure code, my web application firewall is just magically going to protect me, that just doesn't work. You have to audit your code and be secure and all that other kind of stuff. And like with Fastly, we allow you to write your own custom VCL. VCL is basically like running, code at the edge on your CDN. So on every request, the code runs. That's one of the cool things about Varnish, which we've built most of our CDN on. Some folks have written kind of like, if you look here, they're saying like, again, this is blacklisting, so this isn't a good way to do it, but others have done it this way. They say, if there's anything in the request that looks like it might be Java, VB, a script file, etc., then block it. That's why I'm saying like WAFs are a stopgap. They're not a full solution to the problem. The better solution, or the best solution for cross-site scripting is what's called content security policy. These are headers that the server will send. This is a newer thing. It's not supported by all browsers yet, but like Chrome and the latest versions of Firefox, et cetera, support it. But what content security policy is, it's pretty cool. It's a way to tell the browser what it should allow on the site, right? So what you're saying is, for example, cross-site scripting, where it allows you to embed like some, remote JavaScript, so here's a way that cross-site scripting can also be bad. Let's just say I'm a website that gets compromised, like somehow I can overwrite PHP, or there's a cross-site scripting hole, and I can put a link to a malware file that's hosted externally, like a JavaScript that pulls a malware file from external, where any browsers to your website are now compromised because they loaded that JavaScript file, that remote JavaScript malware file. That's like a drive-by download, if you've ever heard that term in the security circles. So what happens is you go to the web page, it's been compromised, it loads the malware onto your browser, and now you're compromised, right? Oopsie. Well, what CSP allows you to do is say, what remote sources and what things can JavaScript do on my site? For example, I think it's on the next slide. Yeah, so here's a good example of that, right? So here's an evil page that's been compromised to run this alert script. But I set the content security policy back here to say script source is self. And what that means, I know that sounds kind of weird. What that basically means is don't allow JavaScript to be executed at all within a page, like within this script header right there. Right? So if an attacker is able to somehow, load this into your database, and then when it gets displayed back on the page, this alert would normally be ran by JavaScript. Instead, the browser blocks it and says, this violates the content security policy directive, script source equals self. So it's a really simple way of getting, XSS protection, as well as other things, as you'll see with CSP. But CSP is a great way of getting kind of like, I don't want to say free, but free. If you go to Twitter, when you guys, not right now because I want you to pay attention, but when you're done paying attention to me, because I need attention, I'm attention starved, look at the headers that twitter.com returns, right? Use curl or telnet, or if you use telnet, like you're old school if you can use telnet to dump headers. But use a tool and look at the headers of twitter.com. And what you'll see is they have a pretty extensive CSP policy, because if you can imagine, Twitter is attacked quite a bit, right? It's a very juicy target for an attacker. But if you look at their CSP headers, you can see all the cool stuff that they're doing there. So that's CSP. This is another one that my first week at Fastly, we had, anybody here running like, or know if they run like a bug bounty or anything on your website? That's cool, so very good. So a bug bounty is, there you go, 2. Bug bounty is where you reward independent security researchers for trying to break into your website and telling you what the flaws are. So some people will be like, I don't want that. Well, they're doing it anyways, right? They're doing it anyways. They're trying to break into your site. So what they'll do is the researchers will submit the vulnerability to you, and say, here's the vulnerability, can I get some cash money? Now, some bug bounties pay cash, like Facebook pays like $20,000 of vulnerability, whatever. Other people don't. For one of our vulnerabilities, I sent a Fastly t-shirt to a guy in Pakistan. So it's awesome. I picture a guy walking around Pakistan with a Fastly t-shirt. I think that's the coolest thing ever. So what was I saying? Oh, so this was the reason, that was total tangent. I'm infamous for tangents, if you haven't learned yet in the 10 minutes with me. What CSRF was, and this was the first vulnerability that had actually been reported to me at Fastly, was a CSRF is a way to take advantage of the fact that sensitive data will be sent, like cookies, etc. Like if you visit a website, doesn't matter how you get the browser to visit that website, the security information is passed with it. So what does that mean? Okay, think of it this way. I'm trying to remember if I put an example up or not. Yeah, so let's look at this. So let's just pretend, I know this is weird, but let's just pretend this is twitter.com or whatever, and the actual URL here does something. It's an action. Let's just say it's a post like, transfer funds or something like that, right? This particular, URL post would transfer funds with a destination account ID and an amount, right? So that, if we're all developers here, we know that that's very legitimate code if I was writing a bank application or whatever. Well, how would an attacker get me, let's just say I'm, the person who's logged into this website, how would this attacker get me to run this code? They don't have to actually do much. If they can send you a link, for example, an email that says, hey, check out this awesome photo of this, skateboarder falling off his skateboard and, running into a wall or something like that, right? And you click on that link, they can hide this URL and this post within that click. And if you were logged into this site, let's just, like I said, let's say this is like wellsfargo.com. If you had been logged into wellsfargo.com that day and your session was still active, you would execute that post with those parameters as your user. They can do it via and then now you're thinking, oh, well, I just won't click on any links. Well, you all know with JavaScript, you can submit a form the minute the page is loaded, right? As soon as the DOM is loaded, that form gets submitted, right? So you can say onload this badform.submit. And now they're going to post to wellsfargo.com as you without you even knowing it, right? You're like, what? How the hell does that happen? So the way you protect against CSRF, as just to recap, cross-site request forgery, is, and again, it's not limited to GETs. People think GETs too, but post, you can submit a post as an onload as well, or even an image tag will do it for you. CSRF, this is the way you solve this. As soon as a person logs in, you generate a token that you store locally for that session, and then you write that token as a HTML form private value on every, you don't do it on login. On every page load, you generate a token, and you write that to the form as a hidden value, and then when they submit that form back, you check that those match. Right? Because there's no way for an attacker to know that session or that value that's been generated on every single form load, right? And I know you're going to be like, you're going to be like, well, this doesn't help me. I need more information. Like I said, Google, get more information. I'm just trying to get you aware of some of these techniques that attackers are using. So some people say like, oh, and this is where it gets really hard. Anybody here write like single page apps with like Ember and Backbone and stuff like that? That gets really hard, right? To start to generate things, and trust me, we know that very well. So I would definitely recommend, we did some stuff around like CSRF with CDNs gets really difficult as well. If you're passing your entire site through a CDN, like Fastly. So we put a blog post up right here. I know you're going to remember this before I change the slide, but you could Google Fastly and CSRF. But we talk about how you can actually cache that CSRF token out on the edge as well. But anyways, there's hacks. Some frameworks like Flask have a plugin that instantly does it. Rails has a plugin that makes it all pretty simple. But it's just one of those things where most people don't even think about these CSRFs, but these researchers, these remote researchers that go in, there's a list probably of like 20 things they do to every site. So if you have a CSRF vulnerability right now, they'll probably submit it to your security team. And am a fan of bug bounties because you want to have a good relationship with these security researchers, right? I mean, they're the gray hats. Like the black hats are the ones that won't even tell you you've got a vulnerability. They'll just break in and steal all your money. But then there's the white hats, which are usually on the other side to try to defend against it. The gray hats are the ones that look for vulnerabilities and then report it just trying to get money, right? It's a way for them to make a living. And I love being friendly with the security research, groups, because while they're looking for money and they're doing it as part of like kind of a job, I mean, but they also are providing you a lot of value. Like it's very hard to hire security people. So if you can get almost like, low cost like security audits, how great is that? First party cookies. So related to the CSRF stuff, what's cool about this is a new standard that Google just, I think it's Google, yeah, Mike West at Google's pushing out. It's not really supported that much left yet, but what it does is you can make it where cookies and things like that they can only be loaded from the same page, right? So if you remember what I talked about, how an attacker gets you to load a page over here that doesn't post to a site like wellsfargo.com over here, a first-party cookie would mean that this cookie is only accessible if the browser bar where it was submitted from was of the same domain as the site it was going to. So this one's a newer one, but I would definitely recommend people look at this because this will be really cool when all the browsers support it. So SQL injection. This is another one people run into a lot, and there's a lot of PHP developers out here. PHP is notorious for being vulnerable to things like SQL injection. How many here have built a query string like this with a string where you like concat like the get or the post dictionary values, and you just blindly create this SQL statement from parameters? We've all done it. Come on, I've done it. Let's heal together. It's a healing session. We've all done it, right? What happens is if I put here, what if user ID equals 99, tick, semicolon, drop database users, right? There's a lot of tomfoolery and mischievousness that can be done with things like SQL injection attacks, right? If I made that the user ID. So this is a really, really common problem. If you see a lot of compromises online of a site, most of the time it's some sort of a SQL injection vulnerability. Even like the bank sites get hit with these all the time. It's basically because people didn't escape similar to the whole XSS stuff where you're trying to escape bad things, SQL injection is another one of those that kind of falls prey for it, right? And so, yeah, it's bad. And you can do things like password dumps or files. I mean, PHP has things like system calls and stuff. I mean, you can fork out to a process running on the machine. When I talk about one of the DDoS attacks a little bit later in the talk, this is exactly how the servers were compromised to run the DDoS bots. So how do you fix it? A lot of most ORMs these days, it seems, auto-escape these parameters for you so you don't have to worry about it. I think, I haven't been a programmer for a while. Like the last framework I really spent a lot of time with was Django. I never say it right, Django. And they had a cool ORM that did a lot of this escaping for you. I know there's a lot of the Java and the Ruby ones will do that for you as well. But don't use string concatenation to make queries. Don't do it. Or if you do, be really, really vigilant about it and use like a library that'll escape it for you. Because there are a lot of, and then parameterized queries, that's another one that'll do it for you. So instead of you doing like a concat, most of the databases now will allow you, they have like function calls where you can parameterize the query items. And then only escape as a last resort because, again, just like with XSS, like trying to do this like blacklist method that says like, well, I won't let them do this, this, or this. Well, when they come out with this technique and you missed it, you're going to miss it. So, and then here, so like how some DBs allow you to run queries like select something into out file, right? Or select from in file. Like this is how like password dumps are read is by pulling in from a file. Or, this is another thing. I mean, this is like, I'm summarizing a whole lot into one statement, but permissions of the DB user of your website is another one that's interesting, right? Does the user that your website is talking to the database with really need terms like drop table? Is there any reason whatsoever to let your website allow a random user to ever run drop table? No. So run your website with a very, very restricted user for the one that that your website framework is using to connect to MySQL or whatever it is. again, WAF, it's not a save all, but again, it's something that you can use. As you'll see here, like some people have used, so they'll look for select froms or delete froms in the query strings that come in, and they'll filter out anything that looks like that. But again, you have to worry about things like language encoding and escaping and stuff like that. This is, again, we call it defense in depth. Like if anybody here like really focused on security, it's like the majority of their life. Cool. So, as you all know, it's defense in depth, right? It's a little bit of everything to try and do whatever you can to protect what you're trying to protect. And so WAF is another one of those kind of defensive depth. It's an arrow in your quiver. It's not something where, like if a WAF salesman ever comes to you and says like, oh, just put a WAF in front of your site and it's magically secure. Like, no, that's horseshit. That's not right. All right, DDoS. Anybody here ever hit by a DDoS attack? It's a lot. I agree. They're terrible. So they're very common these days. I mean, it's a very cheap method of bringing a lot of pain to folks. In my previous life, I think I fought the first DDoS I ever saw in 2001. It was a Tapestry website, and it was under attack. And we came to find out that it was another Tapestry website attacking that Tapestry website. So the Tapestry business is cutthroat, right? Because, if you're a competitor, if I can take your site down, I'm going to go to another site, right? That's simple math. Is that math? I don't know. That's math. Logic. How's that? So DDoS attacks are very common because they're a very cheap way of inflicting a lot of pain on a target website. So, a lot of words here. I mean, I know you're not going to read it, but basically DDoS attacks it's a simple, whereas the previous things that we saw, which were SQL injection attacks, et cetera, the goal of those were compromise, like deface a website, steal credentials, steal passwords, steal credit cards, that type of thing. A DDoS attack has a single Boolean result. Is the site down or not? Or is it slow enough to make it seem like the site's down and someone will go to another site, right? So the attacker wants to generate as much traffic as possible from as little sources as possible. So I think we have, yeah. So like here's a cool image. If you go, again, not right now because we're all fully engaged and paying attention, but afterwards, if you search for DDoS and Pong, there's a super cool video on YouTube that I think it was like the Videoland folks did, where they showed like a normal video. So like these are just like web users hitting the site. Like this is the site over here. This is the end user, and then here's the page on the site, and you'll just see this cool little like, this one will request this page, and this one will request this page, and it's just like everything's nice. It looks like a bunch of fireflies, dancing around. And I wanted to do a YouTube video, but I know YouTube and like PowerPoint don't mix well, so I decided not to. But this is what it looks like when it's under a DDoS attack. It's like everybody's trying to get this file right here, and it's just like sound effects and music, like music in like a minor key. Like this is what a DDoS attack looks like if you were mapping it. And this is what that video shows you. It shows you like the normal happy, like, Peter and the Wolf music playing in the background. And then like the like death metal playing while the DDoS hits. So anyways, where was I going with that? I don't know. It was interesting. All right, so let me give you an example of a DDoS attack. This happened about 4 years ago. And what happened was, I don't know why I capitalized banks. I capitalized a lot of things right there. Basically, so a little bit of history of Brobot. There was a video that was posted on YouTube that was offensive, that some felt was offensive to Islam. Basically, that's what this whole thing started as. And so these attackers, who called themselves, I think it was the Iranian Freedom, I forget it was like Al-Qassam Iranian Freedom Fighters, I think was the full name. They went after YouTube and hit them with DDoS, saying, take this video down or I'm going to DDoS YouTube. YouTube's got a lot of bandwidth. There's a lot of cat videos and like, Justin Bieber videos. Is Justin Bieber still cool? I don't know. But there's a lot, they have a lot of bandwidth, right? So obviously the attackers were not successful in taking down YouTube. So what did they do next? The attacker said, okay, if you don't take this video down, Google, who owns YouTube, we're going to attack all the banks in the U.S. We're going to DDoS attack every bank in the U.S. until the public outcry is so big that you'll be forced to take this video down, right? They'll get a call from President Obama, and he'll say, take that video down, because I'm tired of these banks getting hit with DDoS attacks. That was their goal. So they started just blasting all these banks, right? So here's Wells Fargo saying, like a cyber traffic jam. I love that. That's such an interesting term. But basically, and bro, come on, bro, you guys know why I put that on there? Anybody, right? Come on. Bill and Ted's Excellent Adventure. Thank you. I'm not that old. So basically, so what was this attack? Well, it was targeted at the banks, like I said. It was, so what they did, this is what gets interesting, is how did they were able to generate like 200 to 300 gigs of traffic. I'm going to go on this side. I feel like I'm like favoring this side over here. There's like 200 to 300 gigs of traffic that's being generated. Oh, there's videos over there, though. So that's all right. They don't need to see me on the video. Well, now I feel like I got to go back over there. But 200 to 300 gigs a second, and that's a lot of bandwidth. Anybody have that amount of bandwidth going to their data center? No? Okay. So now see how I came back over here. I love all y'all over there. I just feel like I have to be in the camera. Basically what happened was they took all these shared hosting accounts at like hosting providers like GoDaddy and 1&1 and OVH, right? There's a lot of shared hosting accounts, right? Like $5 web hosting accounts, right? That you can buy from all these providers. And so back in the day with DDoS attacks, they would compromise like grandma's PC with like her 1 megabit a second DSL line with like 256K upstream upload bandwidth, right? That's a very small attacker. They want to generate as much bandwidth and traffic as possible. So I now have to compromise millions of like grandma's PCs to build this really big botnet, right? So they got smart and they said, well, why would we do that when these big hosting providers like SoftLayer, et cetera, have hundreds of servers with gig links in front of them running, 16, sorry, I almost looked dumb there, 16 core, would any of you call me out if I said 18 core? Right, 16 core machines that have a lot of horsepower, right? They got bandwidth, they got a lot of CPU, they got a lot of RAM. So instead of going after individual PCs that I have to compromise millions of, they compromised about 3,000 to 4,000 of these shared hosting accounts. And how did they do that? You remember our SQL injection thing we just talked about? What they would do is there was a flaw in WordPress and Drupal where you could do a SQL injection attack and run code locally on the machine. So they took their little bot code, they, using a SQL injection attack, uploaded that bot code onto that shared hosting account, and then could remotely control the actual DDoS from wherever they needed to be, right? So now I've got thousands of these accounts running on these huge machines with gigabits of bandwidth in front of them. They were able to generate 200 to 300 gigs a second of attack traffic. Now, sometimes with DDoS attacks, you can spoof where you're coming from, because with UDP, UDP is a protocol where it's connectionless, right? You just throw a packet out and hope that it gets there, and then hopefully they respond back to you. There's no connection like TCP is, right? There's no session. It's just like DNS is a UDP protocol. You just basically say like, give me the answer, and then you kind of listen, and then eventually the answer comes back. Well, one of the things you can do with UDP is you can spoof the source. So I can say, hey, give me the answer to www.google.com, but I can pretend like he said it, right? I could like throw my voice like a ventriloquist and make it sound like somebody else said it. And so when you respond back to him. Sorry, I don't mean to pick on you, you're just right there. You'll respond back to him instead of respond back to me, right? So that's how these big spoof DDoS attacks work, is a bot will generate a ton of traffic at that person back there while pretending you're standing over there, so that person will get blasted with a ton of traffic over here, right? Anyways, there's a lot of cool stuff on DDoS that I didn't know if I had time on or not. But so you couldn't be spoofed, and then 200 to 300 gigs a second. I feel like I've been on this slide a long time. I'm going to move to the next one. All right, where do they come from? So you know how you like chant like USA, USA. Like we generate a lot of DDoS attacks. That's what this graph is showing. Like we're the source of a lot of DDoS attacks. So that's not the thing we want to be known for being number one on, right? But this is a cool site. It's called Digital Attack Map that Google and Arbor, I believe, put together. You can go there, again, not right now, and look and see like kind of this real-time, stream of DDoS attacks, where they're coming from, where they're going to, the type of attack that they are, and then like total attack bandwidth. It's a cool site. You just kind of like sit there and be like mesmerized as you watch all these attacks happen. Look at poor Australia over here. He's getting destroyed with that attack. And then obviously, everybody thinks China is the source of most DDoS. China is the source of a lot of DDoS attack traffic. But if you actually look at it, the US has a ton of, it's a lot of compromised hosting machines, et cetera, right? And compromised PCs. So anyways. So how do you block a DDoS attack? I mean, you can do it yourself. This is, like I've given a talk on DDoS where it's kind of like a salesy pitch. This isn't a salesy pitch. This is just saying like, look, you can do it yourself. It's hard. You need a lot of bandwidth. These are hundreds of gigs attacks, right? Not only do you have to absorb the attack bandwidth-wise, you have to have hundreds of gigs of transactional capacity too. Like, can your website handle 200 gigs of actual real requests? That was what was hard about those Brobot attacks as well. These weren't just junk packets thrown at the bank sites. They were using PHP's curl command to craft a get or a post, like a legitimate one, and then just send that over and over and over and over again, like your search page, right? So think of the target of your search form, right? It's like /search question mark term equals dude, right? Like, could you handle 200 gigs a second of that request coming through? I mean, that's what's so hard about DDoS attacks if it's a really good attack, it's really, really difficult to block against. How do you, we've seen attacks where, a lot of you probably use Selenium to do QA, right? Selenium or Water or Phantom.js, there's a bunch of them out there, right, that'll do like real browsers. So attackers now are just, you say, oh, well, I'll just look and I can tell it's curl. I'll just look for user agent curl and block anything on that. We can't do that anymore because they're compromising 100, 200, 1,000 of these Unix accounts. They're running Selenium as making it look like a real browser. And now how do you filter that attack traffic out, right? So sometimes if it's a perfect enough attack, you have to be able to answer all the traffic, right? You can't filter it out in some of those perfect attacks. Anyways, so we recommend you use somebody to do it, right? To help you out. Whether you have an Arbor box on-prem, Arbor is like the most common DDoS appliance out there, or if you pay someone like a VeriSign or a Neustar or Prolexic to do it for you, you might use something like Cloudflare or Encapsula. Akamai does it. You could use someone like Fastly. We can do it with, because one of the ways that we're able to absorb a lot of traffic is we only proxy HTTP traffic. So anything that's not HTTP, like you get some of these attacks are like big DNS amplification attacks, where remember the analogy I used, let's pretend like that guy right there, I'm attacking him, and I'd be like, hey, what's the answer to www.google.com, and I pretend it's him, and then you respond to him, and then I get everybody here to respond to him. All of a sudden, he's just getting blasted with the answer to what's the IP for www.google.com. That's how a reflection attack works. I basically, using UDP and the fact that I can spoof it like I talked about, I get all of you to answer somebody who's not me, and you start blasting him with traffic, right? And again, sorry, I don't mean to pick on you. So with us, we don't allow anything but HTTP through. If it's not HTTP, we just drop it on the floor. So we have 2.5 terabits a second that we just block non-HTTP traffic with. And then if the HTTP traffic comes in, what we've done, and you can do this too, we use Varnish. Varnish, anybody here familiar with Varnish? Have you used it in the past? Yeah, Varnish is awesome, right? It's basically a cool caching, reverse HTTP proxy, and it allows you to run code kind of as part of every request. There's VCL that you can write that will serve a synthetic response, and again, some of this is for the Varnish folks out there. You can have it just drop the connection. We've written in some things with tar pitting that you can do. So you can use Varnish and VCL or other CDN's technology or other providers' technology to write code to look at the HTTP packet, find something that's wrong about it, and then block that. That's hard, right? Yes, sir?
Am I any less vulnerable to DDoS, so certain kinds of attacks, if I use only HTTPS?
Actually, so the question was, am I less vulnerable if I only use HTTPS? No, it's actually tougher because HTTPS, and I'll talk a little bit about it later, is very is CPU intensive. Like when a person does a request to an HTTPS site, there's crypto work that has to happen that doesn't happen with HTTP, so they can actually starve your resources a little bit quicker because of the fact that you have to do these crypto operations on every request. So if they are hitting you with 1 million HTTPS sessions per second, you have to like sign and terminate all those TLS sessions every single time. So you're actually a little more vulnerable. So yeah, I mean, DDoS, I wish I had a better answer for you to how to stop DDoS attacks. There's enough people now that'll help you if you're under an attack for not that much money. It used to be like, $1 billion a month to have DDoS protection. Now the cost has actually come down quite a bit, but we definitely recommend it's part of everybody's thought process, whoever you decide to use. Is be ready. I used to have a whole talk on DDoS, which is why I feel like I'm starting to revert back to that talk. But I usually would just give the recommendation, just make sure you're prepared. Make sure you have a plan in place first, because if you don't and you get hit with an attack, I promise you it's 1,000 times harder to block that attack than if you had a plan in place beforehand. So like right now, actually I'm gonna ask this question, and don't be embarrassed not to raise your hand. How many people here are doing something for DDoS protection? Or no? It's okay if you don't know too, but like if you know. So it's like decent amount, right? And if you don't know, that's fine too, but like, if you aren't, it's really, really, really hard to block an attack when you're under an attack, right? Everybody's running around with their hair's on fire, like, the site's down, right? It's like pandemonium for one thing. And then nothing better for a DDoS provider than somebody who calls them under an attack, right? The guy has pictures of his new yacht in his head when you call and say, hey, I'm under an attack, I really need help, right? Because he or she, don't mean to be sexist there, he or she knows that you're desperate at that point, right? So you're gonna pay a lot more if you're under an attack to get protection at that point, right? That's why people have like under attack fees and stuff like that. So have a plan in place beforehand. And now there's providers out there doing things like overage protection, where like if you get, because another problem that a lot of folks have is they don't know when or where they're going to get attacked or how big it is, but they get charged by the request. I know the camera's over there, don't yell at me. They get charged by the request, right? So if you get hit with a massive DDoS attack, you're paying for all those requests, right? So ask your provider if they'll do like overage protection, where you won't get hit with like $1 million bill, 1 month because you got hit with some DDoS attack. I'm totally like spending way too much time on DDoS, but it's interesting. And if you have questions afterwards, or you want to ask questions at the end of the talk about DDoS, I'll talk about it all day long. Clickjacking, isn't that cool? That's one of the coolest sounding attacks. Do you guys remember that, where you like would mouse over and like you like click the, what was it? It was a squirrel? Click the squirrel. Do you guys remember that ad? Really? No, nothing, not even a courtesy. All right. So clickjacking is another interesting attack where an iframe will be placed somewhere on the site using like Crosssite scripting or one of those, where it'll get placed, and so that when you click on what you think is a legitimate site, you're actually clicking on something else, some other site, right? Maybe you're clicking like they'll proxy that request to an ad network, right? So that the click rate will go up on a particular ad. Like you might want to do that to one of your competitors, where like, they're paying for Google AdWords and you want to click a whole bunch of ads, so they just like their entire ad budget is taken up within like 5 minutes, right? Because they pay per click. But that's what a clickjacking is. It's, how do we solve clickjacking? If anybody want to answer how they solve clickjacking? What do you say? Close-ish. CSP. CSP allows you to protect, remember I told you how CSP is like the coolest thing ever? So it doesn't just protect cross-site scripting, but it'll protect clickjacking, because what it'll allow you to say is, never load a frame from any site except for this site. And this is, what's great about this is it's in the headers. That's not something an attacker can really modify. Like they can use SQL injection to modify your HTML content, but it's really difficult for them to modify a header. And if they do, it's hard to override a CSP header. So CSP is a way for you to say, hey, this frame source, only allow that frame to be loaded from my site. Don't ever allow attacker.com, some sort of frame to be loaded on top of my existing website. So my recommendation is use like Google like CSP and spend like, was it on this page? Oh no, there was another one. It's called cspsawesome.com. If If you go there, they'll help create your CSP headers for you, and then using like Apache mod headers or like Nginx as header support. I mean, everybody's got their favorite HTTP service. Like your CDN will let you override and set CSP headers for you as well. Like spend some time with CSP headers, or tell your security person to do it if you're not doing it today. They're actually kind of cool and interesting. Like they really are, and you're like, yeah, that sounds awesome. No, they're actually kind of interesting, I promise.